Hey everyone, so today we're tackling one of the trickiest puzzles in the entire decentralized web. How do you build private worlds? Let's jump right in.
Look, private spaces are basically the lifeblood of social media, right? Think about your Facebook groups, your private Discords. That's where community happens. But in a world like at AppProto, the whole promise is that you own and control your data on your own server. So how on earth do you build a shared private space without one person having to give up control to another? That's the big question.
So first, let's get on the same page. When we say permission data, it's really just a fancy way of saying any data that isn't totally public. And as you can see, that covers a lot of ground, from private posts to your DMs, even down to your personal bookmarks. But you know, the real stress test, the one that forces all the hard decisions, it's groups. If you can figure out how to do private groups right, pretty much everything else just falls into place.
All right, so when you hear the word private, your mind probably jumps straight to encryption. And yeah, for sure, end-to-end encryption, or E2EE, is absolutely the gold standard for DMs. So the obvious question is, why not just slather it on everything? Well, it turns out that a private group and a one-on-one chat are two totally different animals. This right here is the key insight. The problem you're trying to solve is completely different. For DMs, the goal is confidentiality. You want to keep everyone out, including the server itself. But for a massive private group, the goal isn't really secrecy, it's access control. It's about keeping the wrong people out while letting the right people in. In fact, you actually want the service to be able to see the data to give you things like search and moderation. And that leads to some pretty major real-world problems. If you went with E2E for everything, you'd kill essential features right out of the gate. No search, no good moderation, no recommendations. Plus, you'd be forcing every single app developer and user to deal with a nightmare of key management. And on top of all that, the tech just doesn't scale. We're talking about groups that need to support millions, not just a few thousand. So the takeaway is clear. E2E is a fantastic tool, but it's not the only tool in the toolbox. Okay, so if end-to-end encryption for everything is off the table, what's the alternative? Well, we need a new concept. We need a way to create a shared boundary, a shared context for a group. And that's where the single most important idea in this whole architecture comes into play: permission spaces.
This quote from Daniel Holmgren, the systems designer, just nails it. This perimeter, this boundary for the group, can't just be something an app makes up. If you want different apps to be able to talk to the same private group, which is the whole point, then that boundary has to be baked into the protocol itself. It has to be a fundamental part of the network.
So what exactly is a permission space? The best way to think about it is like a guest list for a party. The space itself defines who's on the list, who's allowed in. But, and this is the crucial part, it doesn't host the party. The data, the actual posts and conversations, that all stays distributed on each member's personal server. So it's not a box that holds stuff, it's a concept that coordinates everything.
And that immediately leads us to the biggest, most important architectural fork in the road. If the data is all spread out, well, where does it actually live? And who's responsible for it?
You've basically got two options. The first is the co-located model. It seems simple, right? The person who creates the group, the owner, just hosts everyone's data on their server. Easy for apps, since they only have to go to one place. The other option is the partitioned model. Here, every single member is responsible for storing their own contributions on their own server.
But when you really think about it, that simple co-located model is a disaster waiting to happen. Suddenly, the person who started the group is on the hook for storing and paying for data from thousands of strangers. They become the default moderator for stuff they didn't write, and if their server ever goes down, the entire community vanishes. It just completely torpedoes the core idea of user control and trust that AppProto is built on.
So the choice became obvious. They went with the partitioned model. Yes, it's a bit more complex for applications to handle, but that trade-off is absolutely worth it to stick to the fundamental principle. It's your data on your server under your control, period.
All right, so we've picked the path that's more complex, but also more principled. So let's pop the hood and see how this thing actually works. How do apps manage to get access and keep all this scattered data in sync? It really comes down to having super clear rules. You've got the space owner, who is basically the bouncer. They don't host the data, but they hold the one thing that matters, the official guest list, the list of who's in and who's out. Then you have the participating members. Their only job is to host their own posts and replies on their own personal data server. And the way an app gets in is pretty slick. The app you're using takes your standard login token and shows it to the space owner's server. The owner's server checks the guest list, sees you're on it, and hands back a special temporary space credential. Think of it like a passport. The app can then take that passport and use it to access the data from every other member's server in that space.
Okay, but that creates a whole new problem, doesn't it? If your app is pulling data from hundreds, maybe thousands of different servers, how does it know it has the latest, most correct version of everything without just re-downloading the whole space every 5 minutes? That would be a bandwidth nightmare.
And the solution is this really cool piece of cryptography called ECMH. The easiest way to get it is to think of it as a cryptographic fingerprint. Each user server generates a single, tiny hash that represents the entire collection of their posts in that space. So now, an app can just compare that one little fingerprint to see if anything has changed. It's an incredibly efficient way to stay in sync. Now, you might know that at Proto uses something called Merkle trees for all its public data. So why not use that here? Well, again, it's about the right tool for the right job. A Merkle tree is fantastic when you need to prove that one single piece of data exists in a giant dataset. But for permission spaces, we have a different problem. We need to verify an entire collection of records all at once. ECMH is specifically designed for that, which makes it way faster and less resource-intensive for this job.
So let's pull the camera back for a second and look at the whole system these pieces create. Because what we're really looking at isn't just a clever way to build private groups. It's a blueprint for a fundamentally different, more open kind of social web.
So, to sum it all up, here are the core pillars. 1. Data is partitioned, which means you are always in control. 2. Permission spaces create that shared boundary at the protocol level so it works across all apps. 3. A single, owner-managed member list makes access control simple and clear. And 4. An efficient sync system makes the whole thing practical and fast.
When you put all this technical architecture together, you get one really simple but incredibly powerful idea. You can finally separate the online community from the application. And if we can do that, if we can embed these rules into the protocol itself, we might just be able to build a future where our private worlds are truly ours, portable, durable, and free from being locked into any one platform. It's a pretty exciting thought. Thanks for watching.